question we did, and then we'll progress. All right. Oops. What's that one here? Hey, what's going on? And we can hold on to this. We can work down on that side with them today, right? All right, cool. All right, folks, evening. We'll just make sure things kind of intact here, and then we'll starting. Right, so we're up and running here on Google Meet. Nobody there yet, though. And we live on TikTok. Right. Yeah, so we'll give you noise a little while to die down. All right, so honey, first here, Jaden have exams. Javier. Right, Jaziri is here, Josiah is here, Julie is here, Noah is here, right? Nyla not here, Paige is Jan out until April. April is here. All right, cool. All right, let me make sure I send you right link. My kids, yeah, okay. We need? Oh.
Awesome. Thank you so much.
Yeah, I had to resist buying some more. They had some new options on the store.
Yeah.
But
You got to let me. Taking my money.
Nah, boy. I had a cart. I had stuff in the cart, and they emailed me to remember, hey, you have stuff in your cart, eh? So I went on, and I just emptied it like, nah, I can't do it right now. Yeah, boy. Hey, go on. Huh? I should probably anyway. Right. Because nobody on that. All right, cool. Right. So we're just gonna recap the last thing we did because we did this piece on Monday. So we recap it and then we'll move forward, right? Just to kind of give a bit of a fresh start. All right, cool. So it says the diagram below shows a triangular field LMP on horizontal ground. Right? So flat ground, that's what they say, right? So we have a north line here. So we have L, M, and P. Right? It says calculate the value of angle MLP. So angle MLP starts at M, goes to L, and goes to P. So that's this angle here. All right? So this is the angle we're looking for. Right? Now, we have all three lengths, right? The magnitude of all three side lengths. What do we need? Pens? Pencil. I have pencils here. Oh. No problem. Right, cool. So if we have all three lengths in a triangle, right angle or non-right angle, we could use cosine rule, all right? Now, the cosine rule normally will give us the length of a side, all right? Now, let's just get the letters going. So if this is L, and that's the angle we're looking for, the side across from, or opposite to angle L is side L, right? If this is vertex M and angle M, that length across from it is small m. And if this is P, that side across there is small p, right? So now we're looking for angle L. So normally we would start by saying, well, using cosine rule, L squared would be equal to m squared plus p squared minus 2 by m by p by the cosine of angle L. Right? Now we want to make this the subject. We have a few things well that currently attached it, right? So one thing we could do, one way to do it is to shift across these two things here. Now both of those are positive and being added, so we're going to subtract them to shift them across. So L squared minus m squared. Yeah? I do, actually. Sorry, give me 1 sec. The calculator is needed. There you go. All right, cool. Right, sorry. Right. So now when you shift it across, the minus, in front of the 2 stays. That minus sign doesn't go anywhere. Right? And that's why cosine L. Okay. Right. So now the understood operation between the minus 2mp and the cosine L is multiplication. And to remove something attached by multiplication, we need the opposite operation, which is division. So we'll divide on both sides of the equation. P as equal to cosine L. And of course, to solve for L now, we have to find the cos inverse. So you can say, therefore, to find angle L, we have to find the cos inverse of that whole thing. L squared minus m squared minus p squared all over minus 2mp. All right, so that's quite a lot. So if you're using a calculator, what I would suggest is work out the numerator first, then press equals, then divide by that denominator, then press equals, and then find the cos inverse of that. So unless you are very skilled in plugging in things into your calculator, don't try to start with this and do the other stuff. Start with the numerator first. Okay. Now let's put in some values, shall we? I feel like I need more space. All right. So we'll continue on up here, right? So therefore angle L is equal to cos inverse. Okay, I think I heard it. Oh. Hey, Aisha, how you doing? Good to have you on. We're trying to finish off the May 2023 paper today. We did 9 part B on Monday, about part 1. So we're just recapping it to give people time to jump in the dance. So, right, so cos inverse. Oh, I still don't have enough room to fit all that stuff. Hold on. Let me just shift it across just to give myself some more room. Right. L was 180, so we have 180 squared minus m, which is 150 squared, sorry, minus 120 squared, right, all divided by minus 2 by m, which is 150, by p, which is 120. Right, so again, this is just calculator food if you know how to use a calculator. Right, so 180 squared minus 150 squared minus 120 squared equals, right. Now we're going to divide that, open your brackets, by minus 2 by 150 by 120, sorry, close brackets, equals, right. So 0.1125. Cos inverse of 0.12, which is actually exactly equal to 1/8. All right, therefore, sorry. All right, ladies. So next week then, right? Okay, later. I think about 20 US. No, about 20 US. Mm-hmm. Oh, okay. Well, I can. Okay, no problems. In person or online? What time? Okay. Cool. All right, sorry. So therefore L is equal to, right. So let's, so second function cos inverse, right. So 82.8 approximately, right? So 82.82 degrees. Correct to 2 decimal places. That's not answer. Hey, cool. All right. Hey, Khalifa, how you doing? Come in, have a seat. So this is trigonometry. This is trigonometry. Yeah. All right. Yeah. We just went over the very last thing we did on Monday, Khalifa. So you didn't miss anything new. So we just did the same work and get the same answer, right? Okay, cool. Um, hold on. Let me just tell Donovan good evening. Even Donovan, how you doing? So yeah, we just kind of recap the very, very last thing from Monday, so you didn't miss anything new. So we're now going to go into the new part of the question, right? Yeah, the time. Oh, let me just mark with your present. Right, so Donovan is here. Lisa just came in too. I've seen Liam or Logan or Nyla. Yes, right. Okay. Right. Okay, cool. So, right. So there we go. Right. So they want a couple other things now. So the bearing of P from L is 210 degrees. Find the bearing of M from L. So I think I'm going to have to copy and paste this page so we could actually see what we're talking about. So, and of course, yeah, let me just take off. Hold on. Can I? Yeah, okay, I could do that, right? Okay, right. So with bearings, right? Right? When they give us the bearing of one point from another, right? The bearing of P from L is 210. So we had to start at L, right? So the bearing of P from L is 210 degrees. And what is the bearing? The bearing is the clockwise angle starting from the north line at the starting point and until it reaches the line connecting the 2 points, right? So it is the bearing of P from L. This is the line connecting P and L. L is the start point. Sorry, one second. Hello, good evening. Aha, yes. Oh yeah, Shiloh is great. I think he was finished with that ear infection by the next day, but we kept giving him the meds as per doctor's instruction up till this morning. And yeah, he never had a fever. Only thing was what like in the night, like he gets a bottle around 2 o'clock and then he starts coughing a lot after that. And that's a recent development. I don't know if it's related. But we'll see if it happens again tonight. But in terms of the ear infection, I mean, I do have a otoscope to look inside, so I don't know if it's cleared up, but it doesn't seem to be bothering him. And he hasn't made any reference to his ears ever since Sunday. Okay, cool. Yeah, that's on like a plan. Thanks very much. Great, as per usual. Okay, great. Thank you very much. Okay. Bye. Sorry, guys. The doctor was just calling to check up on my son. We carried him to the doctor Sunday because he had an ear infection. Right. Sorry. D'Angelo, good evening. How are you doing? We are trying to finish up the May 2023 paper. We started just by kind of going over the last thing we did on Monday, which was to find the angle L, right? And now they want us to find, right. So they want us to find the bearing of M from L, given that the bearing of P from L is 210, right? So we did a diagram here. So the bearing of P from L is 210. So they want the bearing of M from L, right? Now that would be just this angle here. So in order to find the green angle, right, what we could do, right, now in part one, we found that blue angle, right? So if we wanted to find the green, how will we find the green? If we know the pink and the blue. That's correct. All right, so this is 82.82 degrees. Right, 82.82 degrees. Right, so therefore to find the bearing of M from L, which is the green angle, we'll simply subtract 210 minus 82.2. All right, so bearing of M from L is equal to 210 degrees minus 82.82 degrees. Yeah. Okay, cool. So 210 minus 80 is 130. 130 minus 2 is 128. 128 minus 0.82 is 127.18. right? So once again, they wanted the bearing of M from L, which is this point here from this point here. And that's given by the green angle, right? The clockwise angle between the north line at the start point and the line joining the 2 points, right? Now, we were given the pink angle, the bearing of P from L. And in the previous part of the question, we found the blue angle. And we noticed that if we took green plus blue, you get the pink. So if you take pink and then minus the blue, you get the green. All right, cool. Yo. Oh, yeah, sure. I had one here just now. Oh, okay. You have a sharpener? All right. So I share D'Angelo and Donna. One is giving a quick G in the chat if you're good with that. If you need me to re-explain, it's not a problem. I don't mind going over. Let me know what's going on, right? Re-explain. All right. So once again, what they wanted us to find. Hold on. Okay, so let me take off this stuff, right? So the information gave us the bearing of P from L as 210, right? The bearing of P from L is the clockwise angle between the north line, the start point, and the line joining the 2 points. So this whole angle here is the bearing of P from L. P from L, and that is 210 degrees. In the previous part of the question, we actually found this angle on the inside here as 82.82 degrees, right? So we're going to just put that one in blue for now, right? So this angle here was 82.82 degrees. Now, what they want us to find is okay, look at this, right, is the bearing of M from L, right? Now, the bearing of M from L, again, is the clockwise angle between the north line at the start point and the line connecting the 2 points, which is this angle here, right? And what you notice is that if you take green plus blue, it'll give us the same as the pink angle. So if you take the pink angle and you minus the blue, you get the green. Right? So CPU, let me know if that's a little better, right? Yeah, and low too. Okay, ladies, you're okay with that one there? Yeah? Okay. And this piece now, last piece. So calculate the value, sorry, hold on. Right, calculate the value of angle NLP and hence find the bearing of L from P. So calculate the value of NLP. All right, so hold on. Actually, hold on. I'll do that. Oh, yeah, the printer have. I don't have much, but I don't think I might need that much. All right. All right. So we could take this piece off. Right. Take that piece off. Right. So the angle they want, sorry, is what? Is it NLP? Yeah. They want angle NLP. NLP. And then hence find the bearing of L from P. Well, don't we have P from L? Well, we could do L from P. We don't have to find anything else. So NLP. Okay. So first things first, the angle they want, NLP, right? So that's N, that's L, and that's P. So the angle they want is this angle here. All right, so calculate the value of that angle. Now that's actually pretty easy because if we take out the green and we take out the blue, correct. So the orange should make up the full 360, right? So this orange is actually pretty easy. So that's equal to 360 minus the 210. Sorry. And that's equal to 150 degrees. So that's that value there, right? And then they want the bearing of L from P. Okay, so what we need to do on top of that is we need to put a north line at P, right? So they want this purple angle here, right? And again, if you extend this line here, joining 2 points, right, we will see that this angle here. So if we just call this angle theta, the angle on top here is also theta. And if we notice, this is a straight line, right? And the whole angle on a straight line is how many degrees? The whole angle is 180. And the orange plus the purple is equal to 180. So to find the purple, all we have to do is exactly correct. Very good. So 180 minus the 150 is equal to 30 degrees. Right? Right. So let me just recap that real quick in case anybody didn't catch it the first time around, right? I'm going to take out some of the extra stuff there. Everything going to go back, so don't worry, right? Okay. Okay, right. So what we're saying is they told us to find the value of angle NLP. Angle NLP is this angle here. And if you notice, now we have a whole circle. And the total number of degrees in a full circle is 360 degrees, right? So if we have 210 on the right-hand side, I guess I could say the orange portion on the left-hand side would be simply the difference between 360 degrees and 2. I don't know why I keep putting a dot over the 1 or no, like it's an I, right? And that's equal to 150 degrees, right? So that's this angle here. Now, what they want us to find is the bearing of L from P. So we need a north line at P. And the bearing is the clockwise angle between the north line at the start point and the line connecting the 2 points, right? So to find that, right? So what we could do, let me just actually, yeah. If we extend, sorry, 1 second, my bad. If we extend the line joining P and L, right? What we notice is if it just kind of focus right here, you'll see is a straight line, and that's the angle on a straight line, which is 180 degrees. And if we have the orange portion, right, being 150, the portion on this side here will be equal to 180 minus 150, not so? Right. So this portion here is equal to 180 degrees minus 150 degrees, which is 30 degrees. 30, right? Right? And this angle here and this angle down here, the bearing one, are equal because of F angles, right? There are two parallel lines. All north lines are parallel, so there are two parallel lines and a single line, right? A single line kind of running through them. So it creates the F angles. Okay, cool. All right, so Google Meet, so Aisha, Donovan, and D'Angelo. If you guys are good with that, just kind of give me a quick genie chat, please. Hey, James, how you doing? What vibes? Is done. Ali? All right, okay, right. Donovan, Aisha, right. Okay, ladies, are we okay with the bearing of L from P and how I found the different parts? Okay, cool. Right, so let's go on to the last question paper, which is question 10. So we have some matrices of transformation here. So I'm just going to kind of walk you through and give you the answers because we didn't get to do this topic as a whole. And it's very time consuming. So, I mean, there's no excuse not to do it, to be honest. I really should find a way to do it. But I have replays, you know. Okay. Okay, hold on. Okay, so the matrices A and B, and let me just clarify because I'm seeing something not showing up properly, right? So this is, there's a minus in front of that one, right? It's not very visible, but I'm right? Hey, Suraya, right? The minus here and a minus here. Right, so the matrices A and B represent the transformations given below. So matrix A represents an anti-clockwise rotation of 90 degrees about the origin. And then matrix B represents a reflection in a straight line y equal to minus x. Determine the elements of the matrix C, which represents an anti-clockwise rotation, which is A, followed by a reflection in a straight line. Okay. So when you have matrices of transformation and you want to do multiple transformations, right? Long story short, all you have to do is multiply them together, but you have to be careful about the order, right? So in this particular case, you want a single matrix C, which is a combination of matrix A and matrix B. So normally we would write left going right. So we normally say, okay, we're doing A first, then B. But when you're talking about what we call compound transformations or sequential transformation, as in one transformation, then the next one, right? You can actually, instead of having to multiply by one matrix, then the next one, you can multiply all the matrices before, but you have to go in a particular order. So if we did A, then B, we actually have to reverse the order when multiplying. All right? So the matrix C will be equal to B by A. Right? And that's 0 minus 1 minus 1, 0, which is this one here. Then multiplied by 0 minus 1, 1, 0. All right. So how do we multiply matrices again? We multiply row by column. So 0 by 0 will give us 0. Minus 1 by 1 will give us minus 1. Right, so 0 plus minus 1. Now, same row, but different column. 0 by minus 1, anything by 0 is 0. Minus 1 by 0 will also give us 0. So here we have 0 plus 0. Now, bottom row, first column. Minus 1 by 0 is, and 0 by 1 is. So in that case, there we also have two other zeros, not so? All right, so let's and then last row by last column. So minus 1 by minus 1 is positive 1, and 0 by 0 is, so you have 1 plus 0. Right. Now, when we simplify, so when you have 0 plus minus 1, you basically have 0 minus 1. Now, 0 plus 0 is 0. Same thing here. And then 1 and 0 is 1. So long story short, you'll get minus 1, 0, 0, and 1. Right? Right? And it says describe geometrically the single transformation represented by C. Right. So again, we didn't do this topic in class because we kind of ran out of time before we started the revision for mock. I'll see if maybe in the Easter we could just go through it kind of quickly. Right. But what I could tell you is that this particular matrix here, this item here, matrix C, this is a reflection in the y-axis. Right. So, like I said, I know we didn't go through it, so I don't know if it makes sense to ask if you understand why which matrix is what or why this is that. But in terms of the multiplication of the matrices, are we okay with that? All right. And again, if you're doing multiple sequential transformations like A then B, right? In the multiplication, you'll have to list them going right to left as opposed to left to right. Because what happens is you're going to be multiplying by the coordinates here. So you're going to multiply A first, then multiply that by B, etc. Right? Okay, so that's that part there. Yeah, I mean, I sort of finish copying it down. Second, huh? J boy 44 boy. January exam results available tomorrow. Apparently they change it. New date, 20th of March. All right, cool. So next page, let's go. All right. A transformation T is defined by the following matrix. the following 2 by 2 matrix. So we have 1, 2, and then Kn minus 1, where K is a constant. Yeah. See, I draw arrow. See? Okay. Right. So a transformation T is defined by the following 2 by 2 matrix. So T is 1, 2, and then K minus 1, where K is a constant, right? But it's an unknown value. So most likely they're going to ask us to find that value. Now it says T maps 2, 3 onto the point 850. Now what does that mean? Now when you have transformations, you can do them graphically or geometrically. Graphically is the better word, right? You can literally draw them out. Or you can use matrix multiplication. Right? So matrix multiplication, one of the applications is facilitating transformations. So what this means, what they're telling us here is that we took this matrix, multiplied it by this pair of coordinates, and got this as the output. So what it would look like is this, right? So 1, 2, K. Sorry, I want to write that a little better, right? So 1, 2, K minus 1, then multiply by. So what we do with the coordinates, we just kind of rotate them or reorient them into a column matrix. So 2, 3. And when we multiply those together, we get the following new position, right? The new point 815. All right. So let's take a look and see how this pans out, right? So like we just did, we're going to multiply row by column. So top row by column, right? So, oops, sorry, hold on, sorry, 1 second. Right. So 1 by 2 is 1 by 2 is, and then 2 by 3 is, right. So I'll write it out. So 1 by 2 plus 2 by 3. And then this row by this column here. So we're doing K by 2 and then minus 1 by 3. So K by 2, correct? And then minus 1 by 3, right? Okay. So yeah, like I said, 1 by 2 is 2. 2 by 3 is 6. 2 by K or K by 2 is 2K. And then minus 1 by 3 is minus 3. And that's equal to 815. Right? As we could see, 2 plus 6 will be equal to 8. So that one pans out. But it also means that 2K minus 3 is equal to 15. So let's pull that. So 2K minus 3 is equal to 15. Correct. So to solve for K, the first thing we could do is we could add these we could add 3 to both sides of the equation, right? So when you add 3 to both sides, all right, so you have 2K there. So that's 18. And now to solve for the value of K, right, we could divide by 2. Why we divide them by 2? Because right now we're multiplying K by 2. And to undo it, you have to use the opposite operation. And the opposite of multiplication is division. And whatever happens on one side of an equation must happen on the next side. So 2K divided by 2 will cancel back down to K. And 18 divided by 2 is 9. And there you have it. Right. So once again, a transformation, right, is given by this matrix, where K is a constant, and it maps this point onto this point. What that means is when you multiply this matrix by this point, you get this as the result, which you can see here, right, in this initial statement there, right? And after that, it's just some relatively simple matrix multiplication and some solving. Sorry. Okay, so Donovan, Donovan, DeAndre, and Aisha. If you guys are good with what's currently on your screen, kind of give me a Genie chat. If you need me to re-explain, that's not a problem. Just let me know. Give me a R. Yeah. That's what I just said. All right. So let's turn the page. You all okay with this? Still copying some stuff down? Finish? Okay, then no problem. All right. So I'll just hold on. WY and XZ. All right, cool. So that first vector is 5 and minus 1, eh? 3 minus 3, 7, and 8 minus 7. So you have each of those vectors has a negative component, but they're barely visible, so make sure you write it in. All right, let me just get a little water. Give Donovan a minute. Um, Everything all right on that side? All right. Okay, cool. Right, sorry. Blank E2V. Do I have solution to P with John 20? Yes, Tommy Ellis. On my channel, on my YouTube, yeah, so you're on YouTube, right? So just check the YouTube channel and you'll see it done in January. It's a live, so you could go back, you can go in the channel, check the lives, and you should see it there. I also did it over, but the January live would be the best one to check, right? Yeah, so anybody on YouTube, sorry, I don't keep the YouTube comments open as I focus on the class. So if you ask me something and I don't answer, it's not personal. It's not like a bad man, okay? It's just that I do have this chat up all the time. Just check it intermittently. Wait, didn't Juliana say she was coming? Sorry, give me one sec. Yo. Where did you come in? All right. Okay, guys, let's take a look here. So we have three vectors, wx, which is 5 minus 1, xy, which is minus 3, 7, and zy, which is 8 minus 7. Now, those are not coordinates, those are vectors. Sorry? Okay. What a vector tells us is how to get from one point to a next. So in the case of wx, to go from, so w is the start point, x is the end point, and the arrow on top indicates the direction of travel from w to x. So to go from w to x, you have to go 5 on the horizontal and minus 1 on the vertical. Now on the horizontal, movement to the right is positive, movement to the left is negative. On the vertical, movement upwards is positive and movement downwards is negative, right? So to go from W to X, it seems we have to go 5 spaces to the right and then 1 space down. So that's W here and that's X. Now we have no idea where W is in the whole Cartesian plane or where X is. We just know where X and W are relative to each other. All right. Now this next one, xy, the vector there is what? Minus 3, 7, right? So that means we're going to go minus 3 on the horizontal, which is 3 spaces to the left, and then 7 spaces up. So that is 1, 2, 3, 4, 5, 6, 7. So that's why something on the top there, right? And then zy. Now zy means to go from z to y. So you had to go 8 spaces to the right and then 7 spaces down, which means to go from y to z, you had to reverse it. So you could reverse or rather inverse any vector by simply swapping the positions. And if you do so, right, you have to change the signs of each of the components. All right. To go from y to z, you would have to go 8 spaces to the left and 7 more spaces up. But I do have 7 more spaces up. Actually, I do. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7 up. So z would be here. All right, so we kind of have a visual of where these things are relative to each other. We just don't know where exactly in space they are, but that's what it is, right? Okay. Sorry? Okay. All right. So again, all vectors are directions, combinations of horizontal and vertical movement. Now you could have horizontal only, you could have vertical only, but most times you'll have horizontal and vertical. Horizontal, of course, you have to go either right or left. Right? Right is positive, left is negative. Vertical, you can either go up or down. Up is positive, down is negative, right? Okay. Mrs. Webb, good evening. Thanks for vibes. Right. Now, the first thing they ask for is a vector other than 5 minus 1 that is parallel to wx. Parallel vectors are simply multiples of each other. So, for example, if I take 2 and multiply it by 5 minus 1, I'm multiplying that 2 by each component. 2 by 5 will give me, and 2 by minus 2 will give me, right? You could even say minus 5 and positive 1, because that would simply minus 1 by this, right? So any number, you can use fractions. You use a half, you can use a third, a quarter, whatever. But they wanted any vector other than this, which is parallel to wx, right? So when vectors are parallel, they're said to have a scalar relationship. The scalar is simply the number on the outside and multiplied by the numbers on the inside, right? So you could pick any number you want, right? I would pick 2 because it's the easiest number as far as I can say. 2 or minus 1, right? But you could use 3, you could use 10. Right. Okay, cool. Right, now WY. Crap, I used that color already. All right, you know what? I'll just shift this to purple. WY. Now, we have W here and we have Y here. We need a connecting point. Are there any common points between them? X. We could go from W to X, and then we could also go from X to Y. So if you put those together, W to X and X to Y, you could go from W all the way to Y. So WY will literally be WX plus XY, which is equal to 5 minus 1 plus minus 3, 7. Right? And when you're adding vectors, you add the corresponding components. So you have 5 plus minus 3, which is just 5 minus 3, and then minus 1 plus 7. 5 minus 3 is 2, and minus 1 plus 7, same as 7 minus 1, which is 6. And if you look at the diagram we have, check it out, right? 1, 2, and then 1, 2, 3, 4, 5, 6. So it ties back to what we have. See? Right? Because, like I said, it had to make sense. And you had to make it make sense. And diagrams help that. As I said, a picture paints 1,000 words. Right? Sorry, I want to join the call. Why am I not hearing the thing? Oh, there's Julie. Hey, Julie. Sorry, I did not hear the notification. Yeah. Yeah, we finishing up the May 2023 paper here, and then we're gonna start the Jan 2023. So what I'll do is I'll send it in the chat in a little bit, right? Yeah. Yeah. I don't know how come I didn't hear the little ding. I'll check the audio settings. Yeah. So as you can see, it's literally the last two questions on the paper. Part 3 and part 4. Right, okay. Now XZ. Right? So XZ means we want to go from point X to point Z, right? Now we have two X's and we have one vector that has a Z, right? What is the other letter in that vector with the Z? The accent? Yeah, right. And which of these has the Y to connect it? XY, right. So to get XZ, we had to go from X to Y and then Y to Z. Right? We had to go from X to Y and then, Y to Z. Right? And as you notice, initially, like I said, they gave us ZY and we inverted the vector to get YZ. To invert a vector simply means to change the sign of each of the components. Whatever was positive would become negative, and whatever was negative would become positive. Right? So if ZY was positive 8 and minus 7, YZ is negative 8 and positive 7. Right? So XY is minus 3, 7, and YZ is minus 8, 7. So in this case, you have minus 3 plus minus 8. So it means you just add them and put back the minus sign. And then 7 plus 7. So minus 3 minus 8. Just now, let's you. 1 second. Minus 3 minus 8 is minus 11. And 7 is 14. Hey, CPU, which particular part are you explaining with? Part 1, part 2, or part 3? Part 1. Right, okay. So just very quickly. Yeah. So a vector other than this, which is parallel to WX. So WX is this vector, right? Parallel vectors. When vectors are parallel, they're said to have a scalar relationship. Right? What that means is one vector is simply a multiple of the other, right? So for example, if I had some other random vector off in space somewhere, let's just say AB, and AB had components, let's say 10 and minus 2. Now you'll notice that you could actually pull out minus 2, or 2, like a kind of common factor. And when you divide, you get 5 minus 1. And 5 minus 1 is W. So this is literally 2 multiplied by WX. So anytime you have a scalar relationship, as in when one vector is a multiple of another vector, whenever you have that type of relationship existing between two vectors, they are parallel, right? And it could be a positive scalar, it could be a negative. Let's say it was minus 3 instead, right? That will give us minus 15 and a positive 3, right? But again, this is equal to minus 3 by the 5 and minus 1, which is our original vector, WX. So once you could identify or show a scalar relationship, that means that the vectors are parallel. So I hope that helps CPU. All right. Okay. We have one more piece, right? Which is this thing where X and Y are between two vertical strokes. Now what that means is they want the magnitude of that. I'll go back on this page because that's where X and Y is, right? All right, so the last thing they want us to do is the magnitude of vector X, right, of XY. Sorry, arrowhead. Right. Now, to find the magnitude, it's simply Pythagoras theorem. So we're going to find the square root of the sum of the squares of each of the components. So the horizontal squared plus the vertical squared, and then square root it. First time, Mrs. I will be on till about 8:30. First time, well, thank you for joining. Good to have you on. You doing the exam, or like you have a kid or a niece or nephew doing the exam? Right, so minus 3. So when you square something, what are you actually doing? Multiplying it by itself. So minus 3 squared is minus 3 multiplied by minus 3. And a minus by a minus is a plus. Minus 3 by minus 3 is positive 9. 7 by 7 is 49. 9 and 49 is 58. Oh, here's stylus. Thank you for following. Love that. Right. Right. So you could plug that in your calculator and get an approximate value. I don't think we could simplify it really. That only has two factors other than 229. Yeah. Yeah. About that. Yeah, that's correct. 7.6. Yeah. 0.6 units. Like doubles and doubles and coffee. Who said doubles and coffee? Curry and coffee, boy. Yeah, I ain't tried that one yet. But here now, but Josiah, you gotta try, you gotta get a hot Americano and doubles, but now it's like that with medium roast. So you eat the doubles and then drink the coffee. I know, very different, eh? Yeah. What lads? What vibes? Good to see you. I swear I see you on the avenue last week. I can't remember what day, no? And like it was, I'm not sure what time of day. But like it's by the gyro people on nearby Republic Bank. That was you. With a female companion. I don't know. Might not have been. But thanks for sharing your life. And Zachary too. What's going on? Good to see you on, man. All right. Okay. Right. So that's the end of the May 2023 paper 2, right? The vectors question this year actually came pretty nice. All right. Okay. Aisha, DeAndrew, Donovan, and Julie, if you guys are good with this item here, let's come up with G. Well, as it was new. All right, no worries. That's cool. That's cool. How the internship going, boy? All right, thank you. Okay, cool. All right. So, ladies and gents, just give me a minute. I have hard copies of the Jan 2023 paper for you all. Oh, Zachary, thanks very much. More than 5 friends, boy. Wow, that's pretty cool. I appreciate it. Right. Okay, so let me just send the paper to the mass people. Right, now everything will be visible on the screen, so you'll always check it out there. But I want you all to have a copy of the paper, should you to print it out or work on it on your own, whatever the case is. So just send in the chat, right? So you could open it there if you want, and in a separate window, you could look ahead, whatever the case is, right? Or we could just work together, right? Okay, so what we'll do, let me just clean up some stuff here real quick. Yeah, okay, cool. All right, and you all were okay with the last couple of questions there? Any issues, problems, anything? All right, and if you were okay with the vectors question, then that last piece there? All right, cool. All right, cool. So, Jan 20. So this one I apparently, I didn't lay it out the same as the regular papers, but it'll work nonetheless. Okay, so go ahead, please start. Yeah. So it says by rounding each number in the expression below to one significant figure, estimate the value of. Okay, so you have to round this off first. Gotta round this off first. So the 108 will become 100. 19.7 will become 20. Yeah, it says to round each of the numbers to one SF first and then do the calculation. So this one, yeah, this one was a little, they catch rid of people with this one. Right? So again, one significant figure. Right. So one significant figure means that the first digit is not 0 and the rest are, all right, in your denominator, right, that'll be 20, and then 5. You can put 5.0 if you want, 20.0 to make a difference. Right, and the square root of 100, as you correctly know, is 10. 20 and 5 is 25. And 10 over 25, what number go into both of them? 5. 5 into 10 goes 2 times. 5 into 25 goes 5 times. All right, cool. Right, so now this one, right, so I'll give you a minute or two to work that out. Just say hi to the people them. People them, hello. Sorry, Donovan. Say that again. Right. So 108 is 108, and you have 3 digits. You have the hundreds, you have the tens, and then you have the ones, right? Now, they said by rounding each number in the expression below to one significant figure, right? So 100 rounded to one significant figure. Now, a significant figure, well, you could consider it like a non-zero digit. Is a digit, if you were to change it, would literally change the entire value of the number, right? Now, when they say one significant figure, they want the first and only the first digit to be not zero. So, like this item here, right? That's 108. So the 1 in the hundred stays as 1 because this is a 0, right? Because you use the same principles of rounding off, right? But what would happen is everything has become 0 because anything else after that don't matter, right? Now, if it was okay, so let's say, for example, let's say you're rounding to the nearest 10 or rounded to 2 significant figures, then you get 110, right? Because then you would need 1, 2 non-zero digits. All right, cool. Yeah, man, no problem. That's what I'm here for. Right, I'm finishing my maths SBA. That time. That's a tough one because right now, it's about 5 of my students actually go through their projects. And I can't find time to do that. So if you want, you can send it. I just don't know when I'll get time to go through. Because right now, things in mock mode. And also preparing for the crash courses after mock. So right now, with our real things in the docket. So I can't guarantee that I could get it in due time. But if you tell me how long, or like when you need it back, maybe I could do it at some point. Right? So yeah, you could send it if you want, but again, I can't promise you when I'll be able to do it or if I'll be able to do it. We should go the calculator going. Nice. All right. So is it ask you what you want to do? Yeah. Yeah. Mhm. Mrs. Webb, yes. Question. I just given some time for the question to be done. I'm going to do it now. Right. So find the exact value of 3 and 3/8 divided by 5/12 plus 1/3. Okay. So in this particular case now, we would do whatever's in the brackets first, right? Which is 5/12 plus 1/3. So let's come down here. So 5/12. Right. Read minds I sent. Look up. Oh, sorry. Oh, hold on. Oh yeah, I said till 8:30. So 1 hour again. That was the question, right? Yes, sir. Right, so 5/12 plus 1/3. Right, so when we're adding fractions, what do we need? A common denominator, which is the LCM. Now, it doesn't have to be the LCM, it has to be a CM, but between 3 and 12 was the common multiple. Correct. Right? Now, 12 into 12 goes 1, and 1 by 5 is 5. Right? Wasn't after that one? Oh, sorry, I didn't see that question. Thanks for sharing live. That's, I don't know. Sorry. Could you type it over? Sorry. I apologize. I can't seem to find it. Right. So 3 into 12 was 4 times, and 4 by 1 is 4. So we have 9 12s. And we could simplify 9 12s how? What's the common factor between 9 and 12? What is the common factor between 9 and 12? 3. So 3 into 9 goes 3 times, and 3 into 12 goes 4 times. Right, cool. So now, this item here is replaced with 3/4, right? Now, to divide fractions, I like to convert these to mixed numbers, right? So 8 by 3 is 24, and 24 plus 3 is 27. And we're dividing that by 3/4. Now, what's the protocol for dividing fractions? We change divisor, and we invert the divisor. So 4 into 4 goes 1 time, and 4 into 8 goes 2 times. 3 into 3 goes 1 time, and 3 into 27 goes how many times? 9 times. So we end up with 9 over 2, which you could leave it as that, or 4.5, or 4.5. Whoa, 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 give yourself. Right, okay. Aisha, D'Angelo, Donovan, and Julie. If you guys are good with this page, just give me a quick Genie chat, please, on top. All right, cool. Thank you. 1 second, eh? All right, next page. 1 second. Right. Let's take a read. Due to the COVID-19 pandemic, the number of available seats in a hall was reduced from 125 to 93. Calculate the decrease, the percentage decrease in the number of seats available. Okay. So we need to know, first of all, by how many seats it decreased. So 125 minus 93. That's correct. And then what we'll do is we'll take 32, put it over the initial number 125, and multiply by 100. 25.6. So do you do bearings? Yeah, we did bearings as a topic in January, and we actually did a bearings question earlier tonight. Yeah, but the lives are supposed to be public on my YouTube channel. Check out my YouTube channel, Save Handle Adaptation, and you should find the lives from January come forward there. But they won't stay public for much longer. Next couple of days, by middle of next week, all those coming down. So make use of them. All right, ladies, are we okay with part B there? Uh huh. What's that? Well, if you're rounding it off, you'll have to round up to 26. Because the 0.6 is 0.5 or higher. So remember, once you have 0.5 or higher, you have to round up by 1. You have like price tags on the. Arigato. All right. Aisha, DeAngelo, Donovan, and Julie, if you guys are good with that, give me a quick Dini chat. I know I just asked it, but ask it for this one too, right? Just to make sure. All right, going again. One part C. Right, so this one caught some people off guard. Micah or Mika invests a certain amount of money in a bank that pays compound interest. Compound interest at a rate of 2.5% per annum. At the end of 2 years, the value of her investment is $7,564.50. Calculate the amount she invests. So they give you this formula here. A, which is the amount at end. Right? So A, so this item here, this is the A. All right? Is P, which is the principal or original value, right? By 1 plus R over 100 to the power N. Right? Where A is the total amount after N years. R is the rate, the interest rate. Right. So what's the value of R here? R is 2.5, right? So let's just make a note, right? So the amount at end is 7,564 and 50 cents. Right? The rate is 2.5%. And at the end of 2 years, so N is equal to 2 years, right? And they want to find for P. They want to solve for P. All right. So what I'm gonna do, what I would suggest, you can write out your formula and then substitute your values inside of the formula and see how you can play around with it or transpose to solve for the value of P. So I'll give you a couple minutes. Sorry? That's what we're looking for. See, it says calculate the amount Micah invests, and the principal is the original amount that was invested. All right. Right. See, it says at the end of 2 years, the value of her investment was that, right? So that's the value at end, not the value at start, right? You come here longer, so I mean, what was he saying? What was he saying? All facts, no printer. Eh? How was he saying? Eh? Well, all right. So A. Oh, so something went wrong there. A is equal to P multiplied by 1 plus R over 100 to the value to the power of N. So A, 7,564.50. 1 plus R, which is 2.5 squared. Right, so what you could do here now is you could try and simplify. Right, so I'll give you again a minute or two to see if you can simplify. Right, let's go. Right, so right, so 2.5 over 100 is 0.025 plus 1, you have 1.025, which is then squared. But to find p, look at it. So you have p multiplied by this thing, right? If we understand multiply between p and that item, and they want to solve for p, you want to remove whatever's attached to p. How is this item attached to p? What operation? So we have to use division to carry it across, right? So you end up doing right. Therefore, p equal to, right? So again, calculate the food, right? So 7564.5 divided by point. Oh my god. Right. Squared. Yep. 7,200. Okay. All right. Y'all okay with this one? You okay with it? Right. Good. Yeah, it'll just be A over the whole bracket. All right. Google Meet. So D'Angelo, Aisha, Donovan, Julie. If you guys are good with that one, give me a quick G, please and thanks. All right. Okay, so we have the algebra, so I'll give you a couple of minutes to sort that out. Sorry, say again? the laws of indices, if you have x to the power a, then raised to the power b, you multiply. Correct. And down here, so y to the a, correct. Yep, that's correct.
Oh, yeah.
So when you divide it, you subtract the indices. Hey, Adriana. Hey, Chrissy, thank you. Hey, Peaches, evening. Right. Oh, hey, Peaches, yeah. Okay. Next question. Right. So when they say factorize, they mean express as a product of factors. So x, y. Okay, let's do each one. X, y is literally x by y. Would you agree? Right. So that's x. Yeah, x by y and y by x is the same thing. It's like 2 by 3 and 3 by 2 is the same thing, not so? Because multiplication is commutative. And y squared is y by y. So between this product and this product, are there any common factors? Because I want to know. Right. So y. And when you pull out the y, you're left with x minus y. We okay with that? Okay. Correct? Right. So xy is literally x by y. Y squared is y by y, right? So what we've done is we factorize each term. To factorize something means to express the term as a product of its factors. Xy is the product and the factors are x and y. Y squared is the product and the factors are y and y. So far, so good? So between this pair of factors, between this and this, are there any common factors? Y. So when you literally pull out the y, you'll be left with the x and that y. Now, this one down here is a little more involved. This is a right, but then it appears there's no common factors, right? This is a special case called the difference of two squares. Right, so this is a special case, right? It actually is a quadratic identity, right? So how we factorize this is simple. You find the square root of each term. What is the square root of x squared? X. So you put that first, because it's first in the expression, right? What's the square root of y squared? Y. You put that second, right? And you put a plus in one bracket and a minus in the next bracket. It don't matter which one you put the plus or minus in because it means the same thing. Right. Now, it says here, hence, simplify the expression xy minus y squared divided by x squared minus y squared. Now, what we could do here is we could use our answers in part A and part B to re-express this. So, exactly, that's correct. All right, so you'd have, sorry, the numerator. So we could simply cancel this and this. So go down. Sorry. Oh yeah, top end. Yeah, that's fine. No, take that one then, because purple and green are like inverse of each other on the color spectrum. But you can take what you want. They said that wouldn't show, well, wouldn't blend.
I wanted to stand out.
That was it. Right, so I would say purple and green. They're on the opposite sides of the color wheel.
Brown.
Is that okay? No. All right. Ladies, are we okay with this page? All right. So Aisha, Donovan, Julie, and Diane. Just give me a quick G if you're good with this page. All right, cool. Next page. Aha! We have some shapes and algebra. The diagram below shows two rectangles, M and N, with the dimensions expressed in terms of x. Right. So for M, the longer one, we have x minus 3 as its length and 3x plus 4 as its width. And for N, the kind of shorter one, we have x minus 3 as its width and x plus 2 as its length. But technically, if you were to rotate N like 90 degrees, if you put N to lie down then, right? This would correspond to this. So it kind of lie on top of it. Anyhow, given that what does it say? Given that the difference between the areas is 64, show that this is equal to 0. Okay. The difference between the what? How do we find the area of a rectangle? Length by breadth, horizontal by width, right? So for M, you'd multiply this by that. For N, you'd multiply this by that, right? So you can work those out. Then they said the difference between those areas is equal to 64. So what I want you to do is I want you to find an expression for the area of M by multiplying these two. Find an expression for the area N by multiplying these two. You started. Right? If you know what to do past that, go ahead. Sorry. Go on, call me. Right here. Okay, cool. Well, tomorrow.
Yeah.
So here it is, right? Caleb probably gonna have an extra physics class in person. So what we could try to do is maybe put you and your girls outside here. Yeah.
Yeah, that's fine.
All right. Cool. Yeah. Later. All right. So for M, all right, so that was X minus 3 by 3X plus 4. So X by 3X will give me, yeah? X by 4. About which other question? What's the question? Which question? Number 3? Uh-huh. That maps P onto Q. P onto Q would be an enlargement. Okay. All right, X minus 3 by X plus 2 as X squared plus 2X minus 3X minus 6. X squared minus X minus 6. Now they said the difference between the areas is 64.
No.
So 3X squared minus X squared is 2X squared, right? Now minus 5X minus X. When you minus a minus, it becomes a plus. Minus 5X plus X is minus 4X. Minus 12 minus 6. That's minus 12 plus 6, right? That's minus 6. And that's equal to 64. Right. Now, if you notice, 2, 4, 6, and 64 are all even. So we could actually divide by 2 and everything. So if you divide everything by 2, 2x squared divided by 2 is x squared. Minus 4x divided by 2 is minus 2x. Minus 6 divided by 2 is minus 3. 64 divided by 2 is 32. And when you're quoting, we bring this across by subtracting it from both sides. Minus 3 minus 32 will give us minus 35. Are we okay with that? Questions, anybody, anything? Okay. All right, Google Meet, you know the drill. If you guys are good with that, give me a Genie chat. If you need me to re-explain, let me know. Get them what color? What section? All right. Yeah, Julie, let me know when you're ready, right? Okay. All right. Following diagram shows three quadrilaterals, P, Q, and R on a square grid. Q and R are the images of P after it underwent two different transformations. So P to R is clearly a rotation of sorts, 90-degree anti-clockwise. We got to figure out where the center rotation is going. And then P to Q is clearly an enlargement because Q is way bigger than P, right? And it looked like a enlargement scale factor 3. Yeah. Right. On the grid on page 9, draw the image of P after a translation by the vector 10 minus 4. Label this image P prime. Right. So remember we talked about translations a bit when we did vectors. Remember when we did the vectors question on the last paper, the last question, and we saw the horizontal and vertical movements, right? So that's what this is. This vector will translate P, 10 on the horizontal and 4 minus 4 on the vertical, right? So 10 on the horizontal means we're moving how many spaces? 10 spaces, right? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 4 down. 1, 2, 3, 4. So here, that'll be the top. And then we could just simply draw in the rest of the shape. All right? And this is P prime. All right, now they also want a reflection in line y equal to 0. The line y equal to 0 is the x-axis. Now, the reflection in the x-axis, right? Okay, check it. If it's, let's take this point. Oh, sorry. Right, so you have 1, 2, 3, 4 4 spaces, perpendicular spaces between this point and the axis. So therefore, its reflection will have the same number of spaces on the opposite side, right? And so then you can go here, 1, 2, 3, 4, 5, 6. And next side, 1, 2, 3, 4, 5, 6. So here, so that point reflected there. So you can just basically draw it in after that, right? And this is P double prime. All right. Okay. Are we okay with these two items here? No? Okay, talk to me. Oh, okay, which one, sorry? All right. Right. Okay. With reflections, each point is reflected one at a time into any mirror line, like I said, right? And the reflection of each point is the same perpendicular distance from the mirror line as the original point. So, right. So if we take this point here, right? 1, 2, 3, 4, 5, 6 spaces down, right? And then its reflection will also be 1, 2, 3, 4, 5, 6 spaces down, right? If they want the very top, right? 1, 2, 3, 4, 5, 6, 7 spaces down, and its reflection will be 7 spaces on the opposite side. 1, 2, 3, 5, 6, 7. So you do that. So you count straight perpendicularly to the from the point to the mirror line, and you count the same number of spaces on the opposite side to get reflection. All right. All right. So Google Meet. Give me a quick G if you're good with the this first page here. Okay. Yeah, describe fully a single transformation that maps P onto Q. Okay. Yeah, it's an enlargement for sure. And you have to talk about the scale factors and how many times bigger is the big shape than the small shape. And you have to say what the center of enlargement is. So check this, right? So look, if you take this side here, that's one diagonal, right? If you take the corresponding side, how many diagonals is that? 3. If you take this one, 2 diagonals, right? No, sorry, you can't take the diagonals there because it doesn't go straight across. Like how this is just a square, right? To go from this point to that point, we have to go down 2 spaces and across 1, right? So if the scale factor is 3, you have to multiply each of those by 3. So if this was 2 and then multiply by 3, you should get 6. If this is 1 and then multiply by 3, you should get 3. So to go from this point to that point, 1, 2, 3, 4, 5, 6, and 1, 2, 3 on the horizontal. So we could agree the scale factor is 3, right? The number of times bigger each length is in the bigger shape than the smaller shape is 3 times. That's the scale factor. You with that? Okay. Yeah. That there since last week. And there's one or all who's up on that side. But maybe it's one of the girls from art math class or something. D'Angelo? I doubt. D'Angelo, either you or Zian had a gray Bliss water bottle. Because it is, oh, heart, sorry, a gray heart water bottle. It just hanging around in class, yes, it's like last week. No, but that was only there after we shifted the tables. It wasn't there before. All right, cool, sorry. Right, so that's the scale factor. Sorry, I shouldn't erase those things. Anyway, right. So first of all, it's an enlargement with scale factor 3. And we have to cite the center of enlargement. So how do we do that? Well, we have to connect the corresponding points. And where those points intersect would be the center. Our feeling is already there. Let's connect a couple more. Right. Right. So you see we connected the corresponding vertices with a what do you call it? With straight lines, and where those lines intersected, right? And if you read down to the x, that's minus 10, and across to the y, sorry, across to the y, and that's 7. So the center minus 10, 7. Right. That's how we fully describe the enlargement. It says an enlargement, give the scale factor, and give the center of enlargement. Huh? All right. 3B part 2. We have to go from P to R. If you look at this shape and this shape, do they seem in the same orientation? Like both of them stand in the same way, or one kind of lying down? One kind of lying down, right? So you have a rotation. Now you could rotate that way or the other way, right? Right. So let's start. Okay. Look. Okay. Yeah. Right. But she making sense, right? If you draw, I'll put like this, right? And you draw the same thing in this shape here, right? Look at how it kind of it did like this, like it fall down, right? So that is a 90-degree rotation, but going anti-clockwise, right? Now you could say that, or you could say a 270 clockwise rotation, right? So we have a 90-degree anti-clockwise rotation. Sorry, I put on the wrong spot. But we're missing one thing: the center of rotation. Right now, center of rotation usually has a kind of slightly difficult. Okay, that's the wrong word to use. A slightly more involved and labor-intensive way to find the center. So remember when we did this one here, we just connected the corresponding vertices, and where they intersected, we got the center of enlargement, right? This one here, to find the center of rotation, you would have to connect the corresponding vertices, yes. But then you have to find where the perpendicular bisectors intersect. Now, another way to do it is this. We agree that there's a 90-degree rotation, right? So just follow for a second here, right? A kind of different way to do it is to imagine that, so this point here and this point here correspond, right? So what we should be able to do is we should be able to draw two perpendicular lines. Both have to be the same length because each corresponding point is the same distance from the center of rotation, right? So these 2 points correspond, so they'll be the same distance from the center, right? So what you could do is you could pick some points at random, right? So for example, let's pick this one here, right? So that point there, if we connect it, right? So let's see if those points are the same next. What we do is we'll analyze the horizontal and verticals, right? So if you analyze the horizontals here, right? We have to go 1, 2, 3 across and then 1, 2 down, right? For the next one, you have to go 1, 2 across and then 1, 2, 3 down. That could work because it's the same 3 and 2, just in different places. So that point there looks to be the center of rotation. Now, I just happen to kind of luckily guess there. What we could do to make sure is we could test the other points, the other corresponding vertices as well. Right? So this is 4 minus 4 and 2. Oh crap. Wait, how do that? Oh, thanks for sharing live lads. I didn't realize you were still there. Right, so let's check it out, right? If we connected this point to it, this point to it. So we have 1, 2, and 1, 2, 3, 4. 1, 2, 3, 4, 1, 2. So same 4 and same 2, right? Just the horizontal and vertical switch. That also corresponds. What about this point here and this point here? Yeah, that'll have to be same because you have to go 3 and then 1, 2, 3, 4, 5. You could go 1, 2, 3, 4, 5 and then 3. So yeah. And if you look at it, if you look at those right angle triangles, doesn't it look like, oh, sorry, well, the lines are very badly drawn, my bad. All right. So doesn't it look like the right angle triangle did this? Right. So that's how you know that the rotation is 90 degrees and it's 90 degrees anti-clockwise. Sorry, anti-clockwise. Okay, so more online people. So Aisha Donovan, D'Angelo, and Julie, if you're good with what on the screen, just let me know. Give me a quick genie jack. All right, cool. Okay. All right, guys. Let's see if we can knock out question 4. This piece of it now. 4A, 4B. Okay. Right. I hear it. Right. So lines L and M are drawn on the square grid below. First thing they want, write down the coordinates of the x-intercept of L. So L is this line here, right? The x-intercept is where it cuts the x-axis. What's the value there? What's the value there? On the x. And if you read across to the y, the value there is 0. So the coordinates of the x-intercept of L are 6 and 0. Right? The y-intercept of M. So the y-intercept of M is this point here. So what's the y value there? Minus 2, right? And the x value is 0. Because if, again, once it... Right, no, the 1 is the x-intercept. All right, the x-intercept is the point on the x-axis that the line passes through. And on the x-axis at any point, y is always 0, right? The y-intercept is the point on the y-axis through which the line passes. And at any point on the y-axis, x is always 0. So the coordinates of the y-intercept of line M are 0 on the x and minus 2 on the y. I just remember once about realize. Hey, Talia, how are you doing? Yeah, that'll be. Okay. All right, that's 4a. Let's check out 4b. The equation of line L is x plus 2y minus 6 is 0. Find the value of k given that the point 9k lies on the line L. Okay, check it. 9 is the x coordinate, which makes k the what? The y coordinate. Now, this is the equation of the line, which is the relationship between the x and y coordinates. So if we were to plug x equal to 9 and y equal to k inside of here, it'll look like this. So x is 9, y is k, and 2 by k is just 2k, right? Now, to solve for the value of k, all we have to do is rearrange, simplify, and solve. So rearrange that. 9 minus 6 is 3. And to solve for k, right? If you want, you could rearrange like this. So we'll subtract 3 first, and then we'll divide by 2. All right, so again, they gave you the equation and they gave you the x value, and you could use that to find the y value. All right, are we okay with that? No? Oh. If there's no, it's not a problem. Let me know so I could go to over again. I could redo it. Okay, let's check out 4c. Find the equation of line. Sorry. Well, I want to pay attention to the explanation. Ramlan. Right. It'll be a self-inverse.
So that's what I'm saying. You get 3 minus x. You get x minus 3 is equal to minus y, which is the same as 3 minus x is equal to y, right?
That's correct.
Which is the same as.
Yeah, that's self-inverse. Yeah.
That's what I told you.
Yeah. Well, that it is. Yeah. No. All right. Right. So to find the equation of the line in the form y equal to mx plus c, first just tell me what is m? M is the gradient. Very good. Do we have a formula for the gradient? Y2. Yeah. You know, m is the you have to use m is equal to y2 minus y1 over x2 minus x1. So we need 2 points from line M. We already have the y. Now, and what is C? C is the y-intercept, which we found in part A to the question. Now, we could use the 2 intercept points, or we could even use any other 2 points to find the gradient. All right? So just for the sake of we could use this point here and this point here. Let's call this point A and that point B. What are the coordinates of point A? 2 on the x and 2 on the y. So that's 2, 2. Coordinates of point B are 3, 4. So these are your y values, these are your x values. So y2 minus y1 is 4 minus 2. X2 minus x1, so you're going to have 2 over 1, which is just 2, right? So now, all we have to do is say, what if we're using y equal to mx plus c, y is equal to the gradient m, which is 2, by x, and c is minus 2. Because we know that from first part of the question. That was the y-intercept. All right. We okay with that one? Any questions? Right? So all we have to do is find the gradient and use that in conjunction with the information we had from part A, which was the y-intercept. Right? So we didn't need to go the whole route of finding the value in conventional sense. Show that by calculation, line L and line M are perpendicular. When two lines are perpendicular, the product of their gradients is equal to minus 1. Now, let's say gradient of L and gradient of M. Now, we just found the gradient of M, which was 2, not so? So what we have to find now is the gradient of L. So with L, we could use, let's use two easy points. Let's use this point here, which is 6, 0, and this point here, which is 0, 3. All right? So for the gradient of L, we're going to use 6, 0, and 0, 3. All right? So again, x1, y1, x2, y2. So using the gradient formula, plus 3 minus 0, 3 over minus 6 is minus a half. So now, if we take the gradient, that gradient of minus a half, and multiply by the gradient we just found of 2, 2 will cancel with 2 one time. A minus 1 by 1 is minus 1. All right, cool. Well, next week then, right? All right, guys. I know it is 7:30. Let's see if we can just do 4-part E real quick now. No? Oh, what? Huh? Okay. Yeah, we just finished. We finished number 4 now. That's fine. Was that sorry? There's somewhere there, yeah. I keep. Oh, thank you. All right, later. All right. So L and M represent the graph of a pair of simultaneous equations. Write on the solution. Okay. To solve simultaneous equations graphically, all you have to do is find the point of intersection. And the point of intersection is right here, where x is equal to 2 and y is equal to 2. And that's the solution. Right. Yeah, guys. Okay. So we will put a pin in there for today. All right. Right. All you have to do is see where the lines intersect. Right? Right. Okay. Yeah. All right. So Google Meet. that's about it for today. If of course you have any questions you didn't get to ask during class, please shoot it to WhatsApp me. It's no problem. Send my picture the question too. Anyhow, I had a cut and run, but apparently my son wake up and he's screaming and crying for me. So yeah, I don't know. So I'll see you all. Usually tomorrow for our maths.
Yeah.
Okay. Right. YouTube.